Welcome to World of Maths. This video we will continue the second chapter polynomial, and this is the last topic from polynomials, which is the relationship between the coefficient and zeros of a polynomial. Please watch the previous two videos before watching this. Also, if you are new to the channel, kindly subscribe. So let's start. So what is the relationship between zeros and coefficients of a polynomial? So there exists a relationship between the zeros and coefficient of a polynomial. We know what is a coefficient and what are zeros. So coefficient of a polynomial is a number that is added to the variable. Usually it is an integer and that is multiplied by the variable attached. For example, 3a. In 3a, 3 is the coefficient of a and a is the variable. In 6 is the coefficient, y is the variable, and we have 5x cube, 5 is the variable, coefficient, and x cube is the variable. So once again, coefficients are the number that is added to a variable. Usually it is an integer and it can be any real numbers, can be positive or negative integers also. And what are zeros of a polynomial? Zeros are the value of the variable that make the polynomial equation equal to 0. So when we replace the value of the variables in a polynomial, which value will gives the equation equal to 0, that are called the zeros of that polynomial. There exists a relationship between zeros and coefficients of a polynomial. So let's see what is the relationship between the zeros and coefficient of a polynomial. For example, let's take a quadratic polynomial. So let's take a quadratic polynomial. The quadratic polynomial is a polynomial which have the highest degree 2. And it is in the form of ax squared plus bx plus c, where a not equal to 0. Let's assume alpha and beta are two zeros of this polynomial. We are assuming that alpha and beta are two zeros of a polynomial. So we know that a quadratic polynomial can have at most two zeros. So we are assuming here that alpha and beta are two zeros of a polynomial. So what does that mean? If we replace the value of x, to alpha, we will get this equation equal to 0. Similarly, if you replace the value of x to beta, it will also give you the equation equal to 0. So we are assuming that a and b are two zeros of this polynomial. In that case, the first relationship is the sum of zeros, which is the sum of alpha and beta. That is a alpha plus beta is equal to minus b by a. Minus b. B is the coefficient of x and a is the coefficient of x squared. So the sum of zeros is equal to the minus coefficient of x divided by coefficient of x squared. So coefficient of x is b and coefficient of x squared is a. So sum of zeros, alpha plus beta, will be equal to minus b by a, minus coefficient of x divided by coefficient of x squared. Similarly, the second relation is the product of zeros, which is the alpha multiplied by beta. The product of the two zeros of a quadratic polynomial is equal to the constant term. So here the constant term is c. Constant term divided by coefficient of x squared. Coefficient of x squared is a. So which is c by a. So the product of zeros will be equal to c divided by a. C is the constant term and a is the coefficient of x squared. So once again, there exists two relationships between the zeros and coefficient of a polynomial. The sum of the zeros is equal to minus coefficient of x divided by coefficient of x squared, and the product of zeros is equal to constant term divided by coefficient of x squared. Let's prove this in a quadratic polynomial. Let's do a problem to verify this relationship. Let's take a quadratic polynomial, which is 2x squared minus 8x plus 6. So first what we will do, we will split the middle term using splitting the middle term method. We factorize the polynomial using splitting the middle term. So here the splitting the middle term, please watch the previous video in polynomials chapter. The first video I have done a detailed video for splitting the middle term. So by splitting, here the middle term is minus 8x. So how we can split this 8x? 8x can be splitted as 6x minus 2x. So minus 8x is, we can split it as minus 6x plus minus 2x. So after splitting the middle term, we can write this polynomial as 2x squared minus 6x. We splitted 8x to minus 6x minus 2x plus 6. taking the common factor, we can see 2x is a common here. 2x multiplied by x minus 3 minus taking 2x common in the second part, we can write it as 2 multiplied by x minus 3. So x minus 3 is a common, that we can write it as 2x into 2x minus 2 into x minus 3, which is 2 into x minus 1 and x minus 3. So the value of polynomial x, 2x squared minus 8x plus 6 is 0. So we can say x minus 1 and x minus 3 are the factors of this polynomial. So 2x squared minus 8x plus 6 is 0 when x minus 1 is equal to 0 or x minus 3 is equal to 0, because the factors of this polynomials are x minus 1 and x minus 3. So when x minus 1 is equal to 0, we can say x equal to 1, and if x minus 3 is equal to 0, we can say x equal to 3. So the zeros of 2x squared minus 8x plus 6 are 1 and 3. So we have find the zeros of this polynomial as 1 and 3. Now let's prove the relationship between the zeros and coefficient. So what is the first relationship? The sum of the zeros is equal to the minus coefficient of x divided by coefficient of x squared. So sum of the zeros of this polynomial is 1 and 3. 1 plus 3 will give you 4. And the coefficient of x here, it is minus 8. The coefficient of x is minus 8, which is minus 8, and we need to put again one minus sign because the relationship is minus coefficient of x divided by coefficient of x squared. So minus into minus 8 divided by 2 will give you 4. So which is sum of the zeros is 4 and the coefficient of x divided by coefficient of x squared is also 4. So we prove this relationship. The second one is the product of its zeros. The product of its zeros is, two zeros are 1 and 3. So 1 multiplied by 3 will give you 3, and it's equal to the constant term divided by the coefficient of x squared. So what is our second relation? The product of the zeros is equal to the constant term divided by coefficient of x squared. The constant term here is, which is a constant term, it is 6, and the x squared is 6 divided by coefficient of x squared is 2. 6 divided by 2 will also give you 3. So the product of zeros are 3, and the constant term divided by coefficient of x squared also equal to 3. So now we can say that relationship is verified here. Let's do one more example. Let us take one more quadratic polynomial, say polynomial of x 3x squared plus 5x minus 2. Again, by splitting the middle term method, we split the middle term here is plus 5x. So we can rewrite it as 6x minus x. We splitted the middle term 5x to 6x minus x. So by splitting, it is 3x squared plus 6x minus x minus 2. Taking 3x is common in the first part, 3x into x plus 2 minus 1 here, and x plus 2 on the second part also. So we have taken x plus 2 as common. So 3x minus 1 multiplied by x plus 2. So this we can say now the value of 3x squared plus 5x minus 2 is 0 when either these are the two factors of this polynomial. So 3x minus 1 is equal to 0 or x plus 2 is equal to 0. So we can say x equal to 1 by 3. If 3x minus 1 is equal to, if 3x minus 1 is equal to 0, then x equal to 1 by 3. Similarly, x plus 2 is equal to 0. X plus 2 is equal to 0. The value of x equal to minus 2. So the two zeros of this polynomial are 1 by 3 and minus 2. Now let's verify the relationship. So sum of the zeros, what is two zeros, is 1 by 3 plus minus 2, which will give you minus 5 by 3. So what is the coefficient of x? My coefficient of x is 5, and we need to put minus 5 divided coefficient of x squared is 3 minus 5 by 3. So which is that the sum of its zeros, it is 5 by 3 is equal to coefficient of x divided by coefficient of x squared. The second relationship, product of the zeros, which is 1 by 3 multiplied by minus 2. So the two zeros are 1 by 3 and minus 2. So 1 by 3 multiplied by minus 2 will give you minus 2 by 3 is equal to constant term by coefficient of x squared. Constant term here is 2 divided by coefficient of x squared, which is 3. So that is 2 by 3. So here we can say it is the product of the zeros, which is 1 by 3 multiplied by minus 2 is equal to minus 2 by 3 is equal to constant term is minus 2. Minus 2 divided by minus 3. So we verified the relationship of the two zeros and coefficient is the problem. Let's do one more example. Let's do one more example. So find the zeros of the quadratic polynomial x squared plus 7x plus 10 and verify the relationship between the zeros of the coefficients. So again, by using the splitting the middle term, we splitted the middle term 7x to 2x plus 5x and factorizing we will get in the same way which we did the previous question. We can factorize as an x plus 2 and x plus 5 are the two factors of this polynomial. So we can say the value of this polynomial x squared plus 7x plus 10 is 0 when x plus 2 is equal to 0 or x plus 5 equal to 0. And when x equal to minus 2 or x equal to minus 5. So therefore the zeros of this polynomial are x squared plus 7x plus 10, which is minus 2 and 5. Now just verifying the relationship, the sum of zeros, the zeros are minus 2 plus minus 5, which will give you minus 7, and the coefficient of x is coefficient of x is 7 minus, so we need to take minus 7 divided by coefficient of x squared, which is 1, which is also equal to minus 7. So the sum of zeros is minus 7 and the coefficient of x divided by coefficient of x squared is also equal to minus 7. The second one is product of zeros. Let's verify that. Product of zeros, that is minus 2 into minus 5 is equal to 10, and the constant term here is 10, which is constant term divided by the coefficient of x squared is also 1. So 10 divided by 1, which is equal to 10. So we have verified that sum of zeros is equal to coefficient of x divided by coefficient of x squared minus coefficient of x divided by coefficient of x squared, and product of zeros are equal to constant term divided by coefficient of x squared. So students, I hope you are clear on polynomials and all the topics which we covered up, which are zeros of polynomial, geometrical representation of polynomial, and the relationship between the zeros and coefficient of a polynomial. Next video we will do the exercise from textbook. Please like, share and subscribe, and also comment if you need more videos from the same topic. Thank you for watching.